All right, guys, so we are now on lesson 9.6. And for lesson 9.6, we're going to talk about solving right triangles. So, what exactly does it mean to solve a right triangle? Now, a right triangle has six things. It has three angles and three sides. So, we know one of the angles is always going to be 90 degrees. Our job is to figure out what are the other two angles going to be and what are the remaining sides going to be. So in lessons 9.4 and 9.5, we use sine, cosine, and tangent to find missing sides. So today we're going to use them, but we're going to use them in a little bit of a different way. We're going to use their inverse function to find the actual angles. Okay. So what do you guys see in these two examples right here is two special right triangles. And by the way, I'm on page 267. Now this right here, it's an isosceles right triangle. Now we do know what these angles are. We know that's 45 and that's 45. But let's pretend for a minute that we don't know that. I know this length right here happens to be 4, and this length right here happens to be 4. And because I know this is a special right triangle, or I can do Pythagorean theorem, I know that's going to be 4 radical 2. Now, I don't need to use all three of the trig ratios. I could use just one. So say, for example, I want to find out what A is. Now, which one should you use? I honestly suggest you guys use the ones where you know the sides are not going to have any radicals or decimals, or they're just whole numbers, which in this case, you actually have that. You have these two. So based on this angle, you have the opposite and the adjacent. Well, out of all of these three trigonometric ratios, which one is going to use only the opposite and the adjacent? Tangent, okay? So the tangent of angle A is going to be, in this case, the opposite, 4, over the adjacent, 4. I put this into the calculator and I get 1. But that doesn't give me the angle yet. All I know is that the tangent of angle A is 1. How am I going to get the angle? Well, there is no algebraic way to find that. You have to use a calculator. Okay, so a little bit of notation to find out what angle A is. The measure of angle A is what we call the inverse function of tangent. And what's going to go in here is actually going to be this value right there. So we're going to calculate the inverse tangent of 1. Now, in the calculator, how do you do that? Let me show you guys. Okay. If you look at these three buttons, you have sine, cosine, and tangent. But right above those, you have sine inverse, cosine inverse, and tangent inverse. You're going to have to use the second function to get that. So in this calculator, you type in the number first, and then second function, tangent. And look, it gives me 45 degrees. We already knew that. So the measure of A is 45 degrees. Now, to find out the measure of angle B, you don't have to do another trig ratio. All you have to do is literally just subtract it from 90, which we already know that's 45. So those are easy. Now, what about the one on the bottom? Now, I know this one's a 30, 60, 90, and how do I know that? Well, very simple. The distance here happens to be 2, and the distance from here to here is it's a radius. So from here to here, it's 4. Why? Because 2 and 2, that's 4. So that means that this is 2, this is 4, which makes this a 30, 60, 90, which I already know that this distance is 2 radical 3. But you know what? Let's not worry about that. Let's use what we have already. So I'm going to talk about, let's just say this angle right here. You could have used that one too. The relation between this angle and this side is that you have the opposite and you have the hypotenuse. So out of these three ratios, which one uses the opposite and the hypotenuse? Well, sine. So the sine of angle B is the opposite over the hypotenuse, which if I were to reduce that, that's just going to be 1/2. So I know the sine of B is 1/2. So in order to get the angle, I have to do the inverse of that. So angle B is going to be, whoops, the inverse sine of 1/2. Now, how do you put that into the calculator? It's really simple, actually. You put 1 over 2, enter. It'll save the answer for you. Then you press second inverse sine, and you get 30. So the measure of angle B is equal to 30 degrees. Now, if angle B is 30 degrees, angle A, all you have to do is subtract that from 90, which we already know that's going to be 60 degrees. So the measure of angle A is 60 degrees. Now, what happens if this is not a special right triangle? Well, that's what we're going to look at next. Okay, please turn to the next page on page 268. And we're going to look at what happens when these are not, when these are not special right triangles. Now, all I know from here is that the distance from here to here happens to be 3, and the distance from here to here happens to be 5. The distance from here to here is 3, and the distance from here to here is 6. So it seems like I don't know anything of my hypotenuse, and I really don't care because I have 2 sides and they're integers, which makes it a lot better. Now, pick an angle. I'm going to pick A in this case. I know the opposite and the adjacent. So out of the 3 trigonometric ratios that we learned, which one uses the opposite and the adjacent? Tangent. So we're going to use tangent. So tangent of angle A is equal to the opposite over the adjacent, 5 over 3. Now what I'm going to do is I'm going to use that ratio to find out what the angle is. So the measure of angle A is equal to the tangent inverse of 5 over 3. Now, if I plug that into the calculator, here's how you're going to do it. Okay. Now, if you have a TI 8986, TI 10 or 16, you can type it in exactly as is. But for my calculator, you know, we're low budget. We got dollar calculators. We do 5 over 3. Okay. Enter. And then press second tangent inverse, and you get that. Now I'm going to round to the nearest. I'm going to round to the nearest tenth, so it'll just be 59. Okay, so the measure of angle A is 59 degrees. So in order to find the measure of angle B, all I have to do now is subtract that from 90. I actually just remembered we actually do need the hypotenuse. Okay, which gives me 34, because if we're solving for this triangle, we need to solve for all the sides and all the angles. So look, I already know that's 9 degrees. I already know my 2 angles. I already know 2 of my sides. Now I just need this. But that's easy. You have 2 of the sides. So in order to find out what that side is, all you have to do is Pythagorean theorem. Do you have to use the trig ratio? You could. You're not going to get the wrong answer. But honestly, Pythagorean theorem works better for this case. So 3 squared plus 5 squared equals, well, segment AB, I'm going to call it C squared. That's 9. 25. C squared, that's going to give me 34. And then when I take the square root of 34, I'm going to round to the nearest tenth. And I get approximately 5.8. So have I solved for this triangle? Do I know all 3 angles? 1, 2, 3. Do I know all 3 sides? This one, and this one, which is 5.8. So I have now solved for this triangle. Now let's move on to the second example in the exploration. Okay, so it's the same thing. We have opposite and adjacent only. So in this case, just, you know, because we're going to be little rebels, we're going to use the different angle right here. Now, the tangent of B is the opposite over the adjacent, 3 over 6, opposite, adjacent, which is the same thing as 1/2. Do you have to reduce it? You don't, because you're going to type it into the calculator anyways. So tangent inverse of 3 over 6 is going to be equal to the measure of angle B. So plug that into the calculator. It's very simple. 3 over 6, enter, second tangent inverse, and then you're going to get, for the measure of angle B, 26.6, because I'm rounding to the nearest tenth. To get angle A, all you have to do is subtract that from 90. 90 minus 26.6, and that is 63.4. We already know that's a right angle, so hey, we've already solved for all the angles. Do we have all the sides? Well, let's see. 3, 6, darn it, we don't. So we need to do Pythagorean theorem. So 3 squared plus 6 squared equals c squared, because that's my hypotenuse I'm looking for. That's going to be 9. 36, that's going to give me 45 equal to c squared. And when you take the square root of 45, not 42, 45, that's going to be about 6 point to the nearest tenth, about 6.7. And that, ladies and gentlemen, is how you solve for a right triangle. Okay, every problem is going to be different. No problem is going to be the same. And it all depends really what you have that will determine what you're going to use. So let me tell you guys where the examples are going to go. At the bottom of page 268, you're going to put problems 1 and 2 right there. Turn to the next page, and you're going to do problem number 3 right there. Now, guys, I'm showing you these because my students have these already. But if you're not my student and you still want to take notes, just write them down on a piece of paper. Okay, so number 4 goes down here at the bottom of page 269. 4 goes right there. And here are all the rules that we're pretty much already using. Okay, you use tangent a lot, but you can really use sine and cosine. And then the next page, problem number 5 goes right there. Okay, so we're going to go ahead and get started with our examples. Okay, so here is our first example. It says determine which of the two acute angles has a cosine of 0.5. So you only have two acute angles. You have A and you have B. So what I'm going to do is I'm going to take the cosine of A and the cosine of B and see which one's going to give me 1/2. So here's A. Now remember, cosine is going to be the adjacent over the hypotenuse. So the adjacent in this case is radical 3. Why? Because this is the opposite. So radical 3 is my adjacent, my hypotenuse is 2. So square root of 3 over 2. Now, if I put that into the calculator, that is not going to be 0.5. Now B, cosine of B, adjacent over hypotenuse. That's 1 over 2. Now, because I'm an expert in fractions, I know that this will be 0.5. So determine which of the two acute angles has a cosine of 0.5. The answer is B, this one. Okay, pretty simple? Sure is. All right, if you need a little bit of extra time to see the problem, make sure you pause the video so you can take some notes. Let's look at number 2. Okay, for number 2, it says let A, B, and C be acute angles. Use a calculator to approximate the measures of the angles to the nearest tenth of a degree. So guys, this is all calculator work. Okay, so for A, you have the tangent inverse of 0.75 equal to the measure of angle A. So let's just plug it into the calculator, guys. Okay, I'm going to put 0.75. Second, tangent inverse, nearest tenth of a degree is 36.9. So 36.9 is equal to the measure of angle A. And that's it. Let's look at B now. Sine inverse of 0.87 is equal to the measure of angle B. So what you're going to do is put it in the calculator. 0.87 second sine inverse, about 60.5. And that's what B is. And the last one for that, cosine inverse of 0.15, put it in the calculator. Oops, I wasn't supposed to put it there. Is equal to the measure of angle C, and that gave me 81.4. So that's the measure of angle C. So I have solved for all three of the angles that I was asked for. It's not an official answer if it's not in the box, you know. And that's example number 2. Okay, so this is example number 3. It says solve the right triangle, round decimal answers to the nearest tenth. Okay, so remember, we're solving for this right triangle, which means that we need to find out what every angle and what every side is. So if you look at this, you have 2 of the sides. So to find the third side, we already have a tool for that, and it's not trigonometry. It's actually Pythagorean theorem. So I need to find out what I'm missing. I am missing segment C, okay? I am missing the measure of angle A, and I am missing the measure of angle B. So those are the 3 things I'm missing. I already know the measure of angle C. That's 90. It's a no-brainer. We don't need it. So let's go ahead and figure out what all these things are. Let's find C first. 3 squared plus 2 squared equals C squared. That's going to give me 9. That's going to give me 4. And then that's going to simplify to give me 13. Take the square root of both sides, and C is going to be the square root of 13. So when I put that into the calculator to the nearest tenth of a decimal, that's going to be about 3.6. Okay, so 3.6. Now I need to find out what A is, or B. Now, it doesn't matter which one you get first, so let's do A. Now, A, I know the opposite and the adjacent, which means I'm going to use tangent. Okay, so the tangent of angle A is going to be the opposite over the adjacent, 3/2. So I'm going to need to find out the measure of angle A by doing the inverse tangent of 3/2. So all I have to do now is just put it in the calculator. 3/2, enter. And then second tangent inverse to the nearest tenth, the measure of angle A is about 56.3. So to find out what angle B is, all you have to do is just subtract it from 90. So 90 take away 56.3, that's about 33.7. Okay? And therefore, you have now solved for every piece in this triangle. All right, let's take a look at example number 4 now. Okay, it says solve the right triangle. Round decimal answers to the nearest tenth. Now, I can't use Pythagorean theorem here because I only know one side, so I have to figure out what H and G are. So let's look at what exactly do I not know. Okay, I don't know what H is. I don't know what G is, and I don't know what angle G is. But that one's easy to find out because you already know that's 25, that's 90. Subtract 90 minus 25, and you get 65. Okay, so I only got two things to do. So it does not matter which one I solve for first because I'm going to end up doing the same thing. So let's solve for h first. Now, I could use this one because it came out an integer, but let's pretend like we didn't know that. So I'm going to use, well, let's see, what am I going to use? I know this is my opposite. I know my hypotenuse. So out of the three ratios that I have taught you, which one uses the opposite and the hypotenuse? Sine. Okay, so the sine of 25 is the opposite over the hypotenuse. Okay, so now what we're going to do is treat it like a proportion, cross multiply. You're going to get 13 times the sine of 25 equal to h. Okay, so 13 times the sine of 25. I'm plugging this onto a calculator. I'm pretty sure you already know how to plug it in. To the nearest tenth of a decimal, that's about 5.5. So h is about 5.5. Now to find g, I could do Pythagorean theorem, but let's do trig. It's more fun. So if I'm looking for the adjacent now, I'm going to use cosine. Cosine of 25 is equal to the adjacent g over 13. Cross multiply, and you get g is equal to 13 times the cosine of 25. Okay, so then that's going to be, well, let me plug it into the calculator. 13 times cosine of 25, that's 11.8. So now I have solved for those two pieces that we were missing. Okay, so this one was example number 4. Okay, we have one more and then we are done. Okay, so your school is building a raked stage. The stage will be 30 feet long from front to the back with a total rise of 2 feet. You want the rake or the angle of elevation to be 5 degrees or less in order to be safe. Is the rake stage within your desired range? So this is a right triangle. They want me to find out what that angle is. So I don't know what that angle is, but I do know the opposite side and I do know the hypotenuse, which is 30. So opposite and hypotenuse, that sounds like sine to me. So the sine of angle x, technical difficulties, the sine of angle x is the opposite or the hypotenuse 30. So I'm going to solve for x. The measure of angle x is equal to x, not a. It's going to be the sine inverse of 2 over 30. Okay, so I'm going to type in 2 over 30 on my calculator. It's going to give me all these numbers. And then I'm going to do second sine inverse, and the angle that I'm getting is about 3.8. So is this less than 5 degrees? Yes, 3.8 is less than 5. So is the state safe? Yes, it is safe. Okay, so yes, it is safe. Cool. All right, so this is the last lesson that I am doing for chapter 9. Please make sure you complete the extra practice section of your journal. Also, make sure you complete the online homework that is still available. I've already given you guys, no, wait, no, I have not. I will be sending you guys a chapter 9 journal again through Remind so that you guys can try printing it out or doing your homework, your study guide on a separate piece of paper and then taking a picture of it and sending it to me through email for credit. All right, guys, stay inside, stay safe, don't go anywhere, and see you later.